Hi, everybody. Welcome to the Invitational Awards ceremony for UT 2020. We're so excited to have you guys here. Today, I'm speaking on behalf of ATX Science Olympia, who are a student-led organization. And we run the Science Olympiad tournaments through UT Austin. And we're so grateful that you all came out and competed in our first ever virtual tournament. I know it's kind of a new thing and a new era. So we're so excited to have you here to hear from our speakers and learn about the awards later. Today, I'll be introducing myself. I'm one of the MCs today, as well as Isha Borker, a finance major. Fedor and Daniel are running the behind the scenes. They're running our technology today. So big round of applause to you guys. Thank you so much for everything. And then here's a picture of all of our team. We're so excited for all of these cool students to be involved in this organization and really excited to work with you guys. Today I'll be introducing Dr. Hawkins. He is primarily interested in a field called Galactic Archaeology, which is aimed at exploring the Milky Way galaxy, its formation, evolution, and structure. And he is also a member of the newly created Wooten Center for Astrophysical Plasma Properties at UT Austin. So give a virtual round of applause for Dr. Hawkins.
Okay, hello everyone. I think everyone can probably hear me, I hope. I am Professor Keith Hawkins. I'm an assistant professor of astronomy at the University of Texas at Austin. And what I'll be talking about is some of the work that we're doing at UT on a field called galactic archaeology. So I'll talk a little bit about what galactic archaeology is and what it's like to be an astronomer. So next slide, please. So what you're seeing here in the background is the McDonald Observatory out in West Texas. And so this is about, I want to say on the order of like 6-7 hours from the city of Austin. And it's just west right outside of a small town called Fort Davis, Texas. And you can see the beautiful observatory that we get to use very regularly, but you can also see this beautiful, beautiful band of stars, and that is called the Milky Way. And so this beautiful Milky band of stars is actually what I study. And it's something that I've studied for quite a long time, actually. And I've been interested in astronomy. I'll talk a little bit about how I got interested in it, but I've been interested in astronomy since middle school, actually. And so galactic archaeology really is, it's a really awesome term to use, but it basically just means that I'm interested in trying to understand how galaxies form and how they evolve and how they assemble. So you want to move to the next couple of transitions. These are all simple questions that, while they seem kind of simple, they're not really all that simple. And these are some of the questions that we work in galactic archaeology. So if you move back once more, move to the next iteration or next, yeah. So I'm like the Indiana Jones of the galaxy in some sense, right? Because I get to go out and explore for fossilized stars in the galaxy and use their chemical patterns to try and piece together the answers to each one of these questions. Even though these questions seem simple, human beings are really still trying to answer these questions. Next slide, please. And so before I get too far into what I do as a galactic archaeologist, I thought it'd be good to talk about, how I became interested in science and what my career trajectory was in science in general. So I got interested in science probably around middle school. In elementary school, I absolutely hated science. I never wanted to be a scientist until I had a crush on a girl and met a girl when I was in middle school and had a crush. And she liked talking about black holes, and she really, really liked the idea of black holes. We used to get in trouble a lot for talking way too much in class about what it would be like to fall into a black hole or where there are black holes really in the universe. And unfortunately, she moved away. And so I reminded myself of her by checking out these same encyclopedias of astronomy. And by the time I got to high school, astronomy just became its own full-blown passion. even though it started from a crush. And I was very lucky. I went to, I did my undergraduate. So once you finish high school, you go on and do an undergraduate degree. And if you want to be a scientist, oftentimes you specialize in some form of science right around the time you're an undergraduate. And so I studied astrophysics, I studied physics, I have a degree in physics, I have a degree in astrophysics, but I also have a second degree in African studies because I was just really interested in, doing things that weren't necessarily related to science. And so when I was an undergraduate, I studied astrophysics, and I went to these various different telescopes, which are kind of pictured here. So this is me at various telescopes around the world that I had the opportunity to either use or visit, mostly use when I was actually an undergraduate at Ohio University. And that's really where I really learned what it meant to be an astronomer. A lot of people think being an astronomer means that you're sitting at the telescope all day, or you're just kind of sitting at your chalkboard writing equations down. But that's not really what it's like to be an astronomer. We don't wear white coats. We don't, we're scientists, but most of what we do is actually computer programming and coding up, how to calibrate data that comes out of a telescope. But I spend probably something like a couple of weeks a year at various telescopes around the world. I spend a lot of time traveling to give talks at conferences. I spend lots of time, making plots and remaking plots and mentoring students. So that's really what it's like to be an astronomer. It's not just the, sitting out and looking at the stars. But after I did my undergraduate degree, I was lucky enough to win a Marshall Scholarship and went on to the University of Cambridge. And Cambridge University was really cool because it was like being at Hogwarts. In fact, Hogwarts is actually modeled after Oxford and Cambridge universities. And so, whenever you went to dinner, for example, you had to wear your academic gown, similar to the film. So that was a really cool experience. And once I finished my PhD at Cambridge, I became a postdoctoral scholar, which basically just means I did more research at Columbia University in New York City. And then finally, I moved here to the University of Texas at Austin as an assistant professor. And so that's kind of my trajectory, and talks a little bit about what it's like to be a scientist and how I became a scientist. Okay, next slide, please.
I'm so sorry to interject, Dr. Hawkins. We just wanted everyone to know they can ask you questions in the chat. There's a link to, sorry, not the chat. There's a link in our description to the tiny URL to fill out Google Forms, so you can have a Q&A with Dr. Hawkins later. Sorry, we'll let you get back to talking about all your amazing work.
Thank you. Yeah, and yeah, if you have questions, I'm more than happy to answer them. I love talking to people about astronomy and space because to me, it's one of the coolest and most exciting things I get to do is talk about space and astronomy, because I just find them really cool. But anyway, yeah. So so that's how I got interested in astronomy, and that was my trajectory. And when I went to graduate school, I decided to specialize in a field called galactic archaeology, where we're really interested in piecing together the structure and history of our galaxy, the Milky Way, using fossil stars. And so this slide is supposed to kind of describe why stars are fossils. And so the best way to describe it is, so you're seeing in here a beautiful cluster of stars, and the best way to explain why stars are fossils is, for two reasons. The first is that distances in space are incredibly vast. And so what that means is that it takes light, which only travels at 186,000 miles per second, which is kind of fast. It takes light very long periods of time to cross space because space is so vast. So when you look up at the sun, for example, which obviously you should never do without protective lenses, right? When you look up at the sun, you're not seeing the sun as it is now. You're seeing the sun as it was about 8 minutes ago, because it takes 8 minutes for the light to go from the sun's surface to your eyes. Similarly, our galaxy is about 100,000 light years across. So when you look up at a star on the other side of the galaxy, you're not seeing that star as it is now. You're seeing that star as it looked about 100,000 years ago. So that's one reason. And the second is because stars, the chemical makeup of a star, the chemical DNA, if you will, generally doesn't change over the course of its life. Kind of like human beings, right? We all have DNA inside of us, and our DNA does change, but it doesn't change by all that much over the course of our lives. And so you can basically, track where a star is coming from based on its chemical fingerprint. And then it's kind of like if you were to, when they dig ice cores in Antarctica and they look at, little bubbles of Earth's atmosphere that's been trapped there for millennia. It's the same kind of concept, but doing it with stars. Okay, next slide, please. Okay, so and so what we do is we try to use these stellar fossils spread across our galaxy to understand how it's structured. And so this is an artist's impression of what our galaxy looks like. It's a barred spiral galaxy, and a lot of people actually get confused. They think that we're sitting at the center of the galaxy, kind of like I moved to Texas 2 years ago, so I'm still learning Texas geography. But imagine, if you will, that Austin, the city of Austin, or the heart of Austin is the downtown. And a lot of people might think that the sun is in the center part of the galaxy, but in fact, that's not quite right. So if you go to the next slide or next transition, I guess, the sun is actually about 2/3 of the way out, about 28,000 light years from the center. And so it's kind of like in Pflugerville or Round Rock or something like that. It's a little bit further out of the center than people often think. And so that enables us to get a really kind of nice view of the Milky Way. So if you go to the next slide, this slide is not just taking an artist's impression, this is a true observation of the Milky Way. And so you can see the Milky Way in all of its beautiful glory. You can see the dust lanes in the Milky Way, which are all the dark bits. You can see all of the kind of the white bits. The kind of the milky part is all of the stars and collection of stars. And then you can in fact see two small little galaxies in the bottom right corner, the large and small Magellanic Clouds, which are other galaxies outside of our own. Okay, next slide, please. And so the Milky Way is my laboratory. And so my slides came off a little bit off-centered, but the center part of the Milky Way is something called the galactic bulge. And the bulge is kind of in the middle of the galaxy. If you go to the next, say, 3 transitions, yes, good, and good. So you have each of these different little components in the galaxy. It's made up by a thin disk. It's made up by a thick disk. It's made up with a bulge sitting in the center. And then on the outskirts, you go by one more slide up or one more transition up, you've got the halo on the outside. And so the way I like to describe the Milky Way in terms of breakfast food, because I really, really like breakfast. So the thin disk of our galaxy is very similar in aspect ratio to a French crepe, a very thin French crepe. And then on the outside, imagine you have your French crepe, and then you put on top of your French crepe a very fat American pancake, okay? And then you dump a piece of butter on top of that big fat American pancake in the center, so that the crepe is like the thin disk, the fat American pancake is like the thick disk, the butter in the middle is like the bulge. And then if you if you put whipped cream on the outside of all of that, that is the galactic halo on the outskirts, and primarily made of the oldest stars. And so that's the way our galaxy is structured. And this galaxy, the Milky Way, is my laboratory. So a lot of scientists, a lot of times people think of scientists being inside of a lab or wearing a white coat with pipettes and stuff. And that's not really what it's like to be an astronomer. But for me, my laboratory is the universe. My laboratory is the galaxy, the Milky Way. And the way I access my laboratory is through telescopes, essentially. So that's kind of the way you can think about it. Okay, next slide, please. And so there's a debate about all these various components, but I won't really go into that. Okay, next slide. Next slide. Yes, and so my research group at UT Austin is pictured here. And we are a group of people. We have about 7 undergraduate students now. We have 4 graduate students and a postdoc, all kind of coming together to answer very difficult questions about how the universe came to be, or how the galaxy came to be. So next slide. And go all the way through the transitions. Yep. So these are some of the questions that we try to answer. Things like, how did the Milky Way come to be? How did its components form? What are the important physics involved? What are the methods that we use? And what are the timescales involved? And how do we use stars? How do stars work? Because stars are fundamental primary tracers. Okay, next slide. Okay, next slide. So the way that we go about answering these questions, some of our methods vary from astronomer to astronomer, but some of the methods that I use are things like galaxy formation simulations. And so this was going to be a video, although I think the video might have been a bit too large, but the video, this was going to be a video that was showing you how galaxies form through a process called galactic cannibalism, where galaxies form by eating up all the small galaxies nearby. And the way what we do primarily in science, right, is we try to, we ask a question, how do galaxies form? We put all the physics that we know into a computer. We simulate how galaxies form, which would have been shown here. And the simulations show that galaxies form by eating up all the small things nearby in a process called galactic cannibalism. And then the next thing after that, if you go to the next slide, So once we have the simulation, we can make a model of the positions and motions and chemistry of the stars in that simulation. And then my job as an observational astronomer is to go out and observe what they look like in the Milky Way and compare those to observations. Okay, next slide. And in order to make those comparisons, the way that we actually measure, say, stellar chemistry, which is what I'm an expert in, is by stellar spectroscopy. So if you can go 2 more transitions, I believe. Good. What you're seeing here is an image of how we actually go about measuring the chemistry of stars through a process called stellar spectroscopy. On the top left, you're seeing you're actually seeing the Pink Floyd album cover, Dark Side of the Moon, where you have white light and you press that white light through a prism, you get the rainbow. But what they don't tell you is what you're seeing in the background image, which is if you look close enough at that rainbow, you'll actually see dark bands that appear in that rainbow. And so what you're seeing here is that this is another way of looking at our sun, our nearest star. If you take sunlight and you pass it through a prism and you look closely enough, you'll see these dark bands appear. And each one of these dark bands is caused by the absorption of a different element in the atmosphere of the sun. And we're very lucky and fortunate at UT Austin because we have these wonderful telescopes which are pictured on the right, where we can actually do this kind of stellar spectroscopic work and really solve for the chemistry of the stars. And so I can look at an image like this and tell you, based on how deep and how broad each one of these dark bands is, how much of each of the various elements, how much of those elements are in the atmosphere of the star. Okay, next slide. We're going to skip this. So next slide. Next slide. There's a lot of transitions here, but this is just showing you that we can actually use the chemistry to chemically fingerprint stars, similar to doing like 23andMe DNA dating for stars. You can skip this. This is kind of what the work looks like. I'm just skipping a bunch of stuff because I'm happy to answer questions about it, but I don't want to take too much time. Yeah, skip that. Yeah, so we wrote this paper just showing that stars born together are very likely to be chemically identical rather than fraternal. You can skip this, and yeah. Okay, great. And then, so stellar chemistry is one way we measure the detailed properties of a star, and we can use those chemical properties to understand how the galaxy is structured. But there's a couple of other things that we use as well, and that's primarily the motions of stars and the positions of stars. So I'll talk a little bit about how we do those. So we measure stellar motions through basically looking at where those stars are and how they're moving on the sky. So we can watch the star move on the sky over many years. And then we can also measure how fast it's moving towards or away from us using something called the Doppler effect. And this is a really great time to be doing this kind of work because the European Space Agency launched a spacecraft called Gaia, which is pictured here. It's this rotating little thing. And so Gaia, if you can go one more slide, Gaia is called the Billion Star Surveyor, and one of the really awesome things about Gaia, if you go to the next transition, yeah, Gaia's going to produce one of the largest and most precise 3D maps of the galaxy ever attempted by human beings, and it's going to do this by measuring the positions and motions for something like 1 billion stars, which is why it's called the Billion Star Surveyor. Okay, next slide. And just to give you an idea of why Gaia is going to revolutionize things a bit, and why I'm really excited about this, and my group is really working on Gaia data constantly. If the Milky Way is here, pictured here, and the sun, let's say the sun is this star here. Now, of course, the sun really isn't that star, but just for purpose of this, let's just say that it is. And go to the next transition. Everything that we knew about the galaxy prior to Gaia, from the 90s all the way up to the early 2000s, up to about 2016 or so, everything that we really knew about the detailed structure was in this very small region around the sun called the solar neighborhood. If you go to the next slide, or next transition, Gaia is really expanding that view from this really small itty bitty space to a much, 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 much larger space. So we're getting now a really large, fresh image of what the galaxy looks like. And that's part of why I'm really excited about studying the galaxy, especially right now. Okay, next slide. This is just saying that, one of the really important things that my group is doing at the moment is we're combining the information that we get from Gaia, which is the positions and the motions of the stars, with the chemistry of the stars that we get from the spectrum of the star, from that beautiful color spectrum. And together, that information is telling us a really important picture of how the galaxy is structured and how it came to be. Okay, next slide. I'm going to skip this. Next slide. And this was supposed to be video, but it's showing, again, kind of large, so it probably didn't transfer properly, but this was kind of going to show you what I'm envisioning us being able to do, especially now. One of the things that my group is working on is actually building one of the very first ever three-dimensional chemical maps of the galaxy ever attempted by any human beings. And so it's kind of like cool because it's being like the first explorers that went out, trying to understand, the so-called new world, but we're doing this with the new world being the whole Milky Way galaxy. So we're not only mapping the positions of these stars and mapping where they are, and we're also now being able to color each star by the chemical fingerprint that it actually has inside of it, by the amount of each of the different elements that it has inside of it. And so what I envision is walking into a planetarium, and so one day you will be able to do this. My group has already built a map like this for the Hayden Planetarium in New York City. You can walk into the Hayden Planetarium now, and you can fly through a 3D visualization, a 3D rendering of our galaxy, color coding each of the various stars by its chemical fingerprint. And that will allow us, I think, to really uncover the structure and nature of the Milky Way. And that's something that I am really excited about. We're also building a virtual reality version of this as well. But the point here is that being a scientist isn't just part of it. A lot of it is right about answering these really important science questions, but some of it is even about making very beautiful visualizations that the public can completely be enamored by, and we could be enamored by as well. Okay, next slide. Okay, yeah, I just want to say that I think the future of galactic archaeology really looks like being able to do this type of work. Right now, we're really limited in what we can do. We can only do this type of really high-level mapping in our galaxy, but we can't do it in other galaxies because the other galaxies are just too far away to get an individual star, to look at an individual star. And so in the future, with things like the Giant Magellan Telescope, the GMT that UT is a part of, as well as other large new facilities, I think we're going to be in a position where we can actually expand this and really start to piece together the structure of other galaxies in the nearby universe. Okay, next slide. That's just showing that. Okay. And next slide. I think that's the end. Yeah. So that's the end of my talk. But it basically, I kind of want to leave you with the fact that, number one, being an astronomer is really, really awesome. It's really fun to be able to go to telescopes around the world and work with data. And in addition to that, I think being a galactic astronomer, especially now with all of this wonderful data coming at us from the Gaia spacecraft and all this really, truly wonderful spectroscopic data coming at us, giving us the detailed elemental fingerprint of the stars, we're now in a really awesome position to be doing galactic astronomy. And so I'll just leave you with the kind of the thought that it's really cool to be the Indiana Jones of the galaxy, and maybe one day you'll all be able to do the same.
Thank you so much, Dr. Hawkins. You guys, that was such a cool presentation, and it was such an honor to hear from the Indiana Jones of the galaxy. I am so blown away for you agreeing to come speak with us. This was such a great gift for all of us. I would just like to, oh, of course, yeah. I would just like to give another virtual round of applause. We are so grateful for you coming out to speak with us, and so excited to see what you'll do in the future. So thank you for coming. Really quick, before we introduce our next speaker, we are going to go back and tell you guys how to follow us on social media so that you can keep up to date with all of our adventures and all of our posts and our future live streams. So I think the slides should come up in just a minute, but there they are. Thank you so much, Daniel. Here is our Instagram page. We are at atx.scioli. We are also on TikTok. We have been producing video challenges, and we're also on Facebook. So please go check us out, and we post lots of updates and cool events like having these speakers. So yeah, thank you guys for tuning in. Go check out our merch giveaway, because we are still taking submissions for that. So if you follow us and like the merch post with the orange leaves and tag a friend, you are entered to win. So yeah, go check us out. Thank you again, Dr. Hawkins. I'm now going to introduce Isha Worker, also in the communications team with me, and she'll introduce our next speaker. So sorry, I almost forgot the fact that you guys submitted amazing questions, and we are excited to ask Dr. Hawkins about those. Our first one, we've got Timothy from Glasgow Middle in Baton Rouge asked what coding program you use.
That's a very good question. A lot of people nowadays, I actually use the Python programming language. It's pretty much ubiquitous now in astronomy to be using Python, and actually it's an industry standard as well. And so my recommendation for anyone that's up and coming that wants to kind of be a scientist one day, coding is a big part of what we do. And so learning a coding language like Python would be really, really helpful if you ever have that opportunity.
Thank you so much. That was such a cool answer. You hear that, middle schoolers and high schoolers, go learn Python. Next up, we've got a question from Anderson High School right here in Austin, Texas. And they said that they have read in a Scientific American magazine that space is constantly expanding. Could you explain how astronomers came to that conclusion?
Yeah, so that's a very good question. I think it's very hard to think about space, right, and space expanding because we're not used to thinking about this on an everyday basis. But the way astronomers figured that out was actually really back in the 1930s. Edwin Hubble was finding other galaxies, and keep in mind back then there was still a debate about whether these clouds, they called them these island universes, these clouds in the sky, these nebula, whether or not these were actually galaxies, right? People just thought they were for a long time people just thought they were nebulae in our own galaxy, that they weren't separate things. But Edwin Hubble comes back in in the late 1920s, 1929 around, and finds that if he maps the motion of these galaxies, these so-called island universes, he found that the further they were away, the faster and faster and faster they were moving away from us. So he not only discovered that the galaxies were moving away from us, which meant that the universe had to be expanding, because things that are moving away, you can imagine rewinding time, things must have been coming back together and closer together. So yeah, that's the primary piece of evidence for the expansion of the universe. But in addition to that, he also discovered that the further something was away from us, the faster it seemed to move away from us. And that now has been called Hubble's law. And so that was kind of the first primary piece of evidence for the expansion of space, the expansion of the universe.
Thank you so much. That was fascinating. I have learned so much today about space. Our last question comes from Pirani in Springhouse Middle School, Pennsylvania. And they asked, what was your most awe-inspiring discovery since you have been studying space archaeology? Or I guess any favorite finds?
Yeah, that's another good question. One of the greatest feelings. And oh, by the way, I didn't realize there were people from Pennsylvania. So hi, I'm from Ohio, so not too far away, or I was not too far away. Yeah, so one of the greatest feelings about being a scientist is the feeling of discovery. There have been moments in my career where I have been the only person in the world to know something. So when I was an undergraduate, I was looking for these objects called hypervelocity stars. These are the fastest objects moving through space, the fastest objects we know of moving through the galaxy. They're moving so fast, they're actually unbound to the Milky Way. They're unbound to our galaxy, and they're moving at something like 2 to 10 million miles per hour. And people have been looking for them for a long time. And I was actually one of the people who discovered some new ones that no one else had discovered. And so I remember that feeling of being in my office and walking home late at night, realizing that I'm the only person in the world that knows that these stars, these fast moving stars exist. So that was that feeling of discovery doesn't come very often, and that's not why I do science necessarily. I do science just because I like being at the edge of human knowledge, but it is a cool feeling to kind of know something and that no one else in the world knows.
Wow, thank you so much for that insight. For all of our future scientists out there, we just like to remind you, stay excited about your STEM classes. This is what comes of it. You get to do really cool research like this and many other forms, and you could possibly be the first in the world to discover something or be the next Indiana Jones of the galaxy. So thank you guys for coming out, and thank you again, Dr. Hawkins. This was wonderful having you, and we're so excited to hear from you. Thanks again. Next up, we've got Isha is going to introduce our next speaker.
Hi, everyone. My name is Isha, and I'll be your speaker, your other MC speaker. So just again, thank you, Dr. Hawkins, and thank you, Becca. Before we continue, I would just like to remind you guys to ask questions to our amazing speakers. There is a link in the YouTube description box, so you guys can use that for our next speaker. So without further ado, I would like to introduce our next speaker, Dr. Ibarra. She is an assistant professor of physiology at Dell Medical School. She researches inflammatory factors of chronic disease, such as heart failure, arthritis, and diabetes. So round of applause.
Hello? Am I on? I just wasn't sure. Okay.
Yeah, you're on.
Okay, perfect. Thank you. Well, hello, everyone. Thanks for joining us, and I'm honored to be here, and I appreciate the invitation to participate in today's award ceremony with you. So my name is Dr. Jessica Ibarra, and what I will do today is just spend a little bit of time, next slide, talking about this word called curiosity. Curiosity, as you might understand, is the desire to know and to learn, and curiosity has played a huge role in my life, in my education, as well as in my career. So I'd like to share a little bit about the role of curiosity in my journey to being a scientist. Next slide. So feed curiosity. This is the first point I want to make, and we'll start with a quote. Next slide. So children are born with all the curiosity they will ever need. It will last a lifetime if they are fed upon a daily diet of ideas. It's a quote by Charlotte Mason. And what I'd like to just point out is that we're born with a certain level of curiosity, and this curiosity is an important part of who you are. And if you already find yourself being that curious person, continue to feed that curiosity. It is important. Feeding the curiosity was an important part of my own journey. And let me introduce to you the ways in which curiosity played a role for me. Next slide. So meet my parents. This is mom and dad for me. So my mother was a homemaker who provided a healthy dose of curiosity at home. Part of her homemaking duties was to really just do the daily task of raising 5 children. And because she was at home with us all the time, she really invested her time in us and found opportunities for us to explore curiosity. My mother would love music, she loved dance, she loved the art, she was highly creative. And anything that we needed to do, my mom found a solution for. So it was through her passion and curiosity and the ways that she solved problems that really helped feed my own level of idea formation and my own curiosity. My dad, on the other hand, was a self-trained, self-developed auto mechanic. And as you imagine, an auto mechanic tinkers with their hands and really knows the ins and outs of an engine. He could take an engine apart in no time at all and put it back together. But combined between my mom and my dad, I really had this sense of curiosity and wonder about life and things, working with my hands, using my mind to solve problems, and also being resourceful. My parents come from very humble beginnings, so we didn't always have the means to buy things to solve problems by getting a service done or purchasing something. So between the two of them, I watched them solve their own problems with unique ideas and creative ideas. And it born within me this thing about being curious to solve problems and to use the things that I had around me to solve these problems. So my parents have been a real huge influence in my pursuit of curiosity. Next slide. There have been several people in my life that also have nurtured this concept of curiosity and this need and to provide a space to be curious. It starts up at the very top with my sister. If you can see up here, it'll say webhead there. My sister was at the forefront of everything, being the oldest. She was the first to go to college, the first to explore life outside of home. And she really mentored and provided a mentoring role for myself to be able to also be curious outside of home, outside of what we considered normal, being the firstborn. In college, I had a professor named Dale Robinson, who was my organic chemistry professor, who also nurtured within me this safe space to provide ideas and be curious. He was the first person to identify within me this thing that I liked about being in a lab and working in a lab. He noted that I was curious and I really like to work hard and said, hey, have you ever considered doing this thing called research? And up until that point, I had no idea what it was to go into science or just to be a scientist. And along the way, I've had many mentors at UTSA, in dental school, as well as in graduate school. And all of these have provided places for me to be curious and to ask lots of questions and to nurture this concept of just creating ideas and problem solving. Next slide. So be curious. What else should we learn about curiosity? Next slide. Let's look at this quote from Albert Einstein. It says, I am neither clever nor especially gifted. I am only very, very curious. And that is actually my story as well. I don't consider myself too clever nor too gifted, but I do consider myself very, very curious. Next slide. So this is me at graduation when I got my PhD. I got my degree from the University of Texas Health Center in San Antonio. I earned a PhD in cellular instructional biology, but I had been there for a long time. I started there as an undergraduate researcher, meaning that when I was in college, I was able to participate in research activities as an undergrad. And then after I graduated, I transferred over there to do a dual degree program. While there, I studied molecular tools, genetic tools, engineering tools, all kinds of tools, and developed skills to be able to study lots of things. I spent time as a teaching assistant, and I also did my postdoctoral fellowship there. Next slide. So the curiosity that I had continued to be nurtured and fed by just exploring things that I was passionate about. Here you'll see a picture of my family, and a few of the members present here have all had some kind of challenge with heart disease. And notice there's an image of a heart there. So heart disease is really prevalent in the Hispanic community and causes a lot of dysfunction and chronic disease. So a few of the folks that you see here have had either a heart attack, cardiac arrest, or heart surgery. And the picture there that you see there with the heart is one that shows my husband that a year ago also had heart surgery. So because of my interest and curiosity in science and medicine, I chose to do my graduate project, or what you call a PhD thesis, on heart disease. And specifically, I was studying the left ventricle remodeling that takes place after a heart attack. And what that really simply means is that there's not a lot we know about how to fix or cure heart disease. In fact, we know so much about it, but it only patches up the effect of it. There is no cure. And so part of my research was to study what happens with scarring after part of the heart has been damaged due to the loss of oxygen, such as in a heart attack. And so again, being curious, asking questions, and also plugging in my passion for my family and things that affect my family were important in my journey through science. Next slide. This is a picture of myself with my grandmother. And if you look really closely, what you'll notice is her hands. So next slide, what you'll notice as we click through it is a magnification of her hands. Well, my grandmother had arthritis, rheumatoid arthritis for many years. It started actually in her mid-30s, and she suffered for a very long time. We actually lost my grandmother 1 year ago. But part of my curiosity for science and learning about factors in the body that affect healing is to also take what I learned from the heart and apply it to a new model, which was a model of arthritis. And so what we do is we know a lot about arthritis, and this is another condition that plagues people, and it's very debilitating and chronic. However, there is no cure. We know that it causes pain. We know that it causes deformity at the joints. We know that it's crippling. We know that there's an inflammatory process that takes place, but to this day, there is no cure. And as we click through this slide, I will show you some other images of her hands. This is me holding her hand in the last moments and days that we had her. And if you notice, her deformity got so severe, you see her trying to hold up a soda bottle. It just really wreaks havoc on the joints, not just of the hands, but all the joints of the body. It was painful to watch her go through this. And I was fortunate enough that in my postdoctoral fellowship, I was able to study arthritis and some of the inflammatory factors that lead to this devastating disease. Next slide. Here are a few pictures of myself as a postdoctoral fellow working in a lab. A lot of the tools that I use are small because everything that we do is in a tube. We're either working at the RNA level, the DNA level, or at the protein level. So my main tools are test tubes, pipettes, cell cultures, as well as looking at specimens under the slide. And so these are the tools that I use to look at some of the things that have been affecting the diseases that I just mentioned, heart disease, as well as arthritis. Next slide. So follow curiosity. Let's look at a quote about curiosity. Next slide. When you're curious, you find lots of interesting things to do. And I can't tell you how true that is, not just for my life, but your life as well. If you're curious, you will find yourself in a lot of different activities to feed that curiosity. Next slide. So this is a picture that was drawn by a student, and this is a student that had a simple task. This is a question I often ask students when I visit schools K through 12. And the question I always ask, if you can imagine for a second what a scientist looks like, what would you draw? It's a simple activity that we call draw a scientist. And the student produced this image. Now, if you look real closely, the person has hair that's standing on end. They've got some little knobs sticking out on the side of their ear. The t-shirt that that person's wearing says crazy, and there's an expression that says boom. It's kind of hard to tell, but if you look at their hands, they're actually mixing something. There's a person walking in the door that says, what did you do? Wow. And so this is a typical image that I get from students when I ask them this simple question. What does a scientist look like? Now, if you click on the next one, what I will show you is some of the common responses I get when asked to describe a scientist. So number 2 says, list 3 words that come to mind when you think of a scientist. You look real closely, it says crazy world domination. Well, I promise you, not all scientists are interested in crazy world domination. And then number 3, if you look real closely, it says, what kind of things do you think as a scientist does on a typical day? List at least 3. So the first one says, puts chemicals into other chemicals to make medicine. Now, I might agree with that. Scientists do drug discovery, and they do mix things together to try to find cures and solutions to some of medicine's toughest challenges. Number 2, it says use computers. Yes, in fact, we do spend a lot of time on our computers, as mentioned by Dr. Hawkins himself. And number 3, it says it tries to make money. Well, in fact, that's actually true too. As scientists, we don't always see the rewards of our work, and sometimes our salaries aren't that great, but there are opportunities to do something that we love, continue to be curious, and make a living out of it. Next slide. So part of the way in which I collect these drawings is to visit schools that are K through 12 during a special time of the year called Fun Week. Now, PHUN is an abbreviation for Physiology Understanding Week. This typically takes place the first week of November yearly, and it's an opportunity to get scientists outside of the walls of a laboratory and into the community. Most of the time as a scientist, you can spend your days at the bench doing experiments, mixing things together, working on a computer. So it's really nice to be able to get out of the lab and enter the community to be able to visit students. And so during Fun Week, because it's a focus on physiology, we talk about the systems of the heart, we talk about the eyes, we talk about anything related to how the body works. And most oftentimes students don't know what physiology is, so we have to explain to them it's a special branch of science that's interested in learning how the body works. So you'll see a lot of pictures of a heart here, you'll see some trading cards, and everybody gets to take home all these goodies with them. Next slide. This is not the only outreach I do. I also like to, in UT Austin, we have something called Explore UT, which invites students to come into our classroom and laboratory space. It's an opportunity for the community, moms, dads, grandmas, grandpas, anybody that wants to come can walk through the facilities, which means coming inside the door of a medical school. And it may be often the first time they see where medical students learn, where they study, and some of the equipment that's available for learning and training of physicians. So here's an example of Explore UT, where we have some of our medical students that are guiding community members through various stations in which they're looking at organs and different body parts. Next slide. Another way in which I like to reach out and step outside the walls of our laboratory is to really go into the community at large. And so one of the things that you see here is during the San Antonio Science Fiesta, I was able to put together a booth that allowed community members to extract DNA, to meet a scientist, to check their blood pressure, talk to physicians, and do various hands-on activities to be curious about science and to really engage with people that we call scientists. On the right-hand side, what you'll see is that I participated at the USA Science and Engineering Festival that takes place annually in Washington, DC. This is an opportunity to engage with thousands and thousands of people that come by the doors of the Science and Engineering Festival. And with the help of the American Physiological Society, you can see me here doing some experiments with different community members. The gentleman that you see there had never, ever participated on hands-on science activities or seen his children and grandkids be part of that excitement. It was the first time he saw DNA being extracted, and he was just wowed and awed. And he also got to see his grandchildren be amazed with the science that they also discovered that day. Next slide. So part of my work as a scientist is not just to stay in the lab or to be in the classroom with K through 12 outreach. It's about inspiring science everywhere you go. And so what you'll notice here is I've had a journey with cancer, and that's me at the top wearing the pink glove. And so part of being a scientist is to be an advocate for care and a patient navigator for people facing a cancer diagnosis. Because of my knowledge and background in science, I'm able to step in where others aren't able and fill in the gap of information and decision-making, and really just helping guide them through the mysteries of what a cancer diagnosis does. I've also been able to participate as a science as a mentor, and you see me there at graduation with one of my mentees, and to really get to allow students to come to your lab, spend time with you. You teach them about science, you teach them skills to either become employed or to continue their educational journey. At the very top, I also do some speaking engagements, and I also like to write about science and share this with the wider community. And at the very bottom are my nieces and nephews and my grandkids. And I really love inspiring them to do science as well. So my granddaughter is wearing a science shirt. My grandson has a journal that he keeps. My nieces down at the bottom are extracting DNA. There's never an age limit to being curious and to exploring science. Next slide. And the last thing I want to leave you with is Awaken Curiosity. This is probably where I spend most of my time when it comes to science, is in the area of awakening curiosity in other people. Next slide. Let's start with a quote. So it says, "Give people facts and you feed their minds for an hour. Awaken their curiosity and you feed their own minds for a lifetime." And isn't that true? You can just give somebody information and it does very little. But if you give them an opportunity to feed their curiosity, that curiosity can spark learning and the desire to learn for an entire lifetime. Next slide. So here are some of the ways in which I'd like to awaken curiosity in our medical students. So we can play games, we can use a simulation environment to teach them about training and responding to emergencies using the knowledge they learn in the classroom in a simulated case. They can also do group work and activities that are designed and geared to collaborate and to exercise teamwork in their learning as well. Next slide. And part of being an educator is to really focus a lot of your time on creating opportunities to awaken curiosity. I really enjoy this part of my job. And part of it has been through COVID and working from home has been, how do I continue to spark curiosity in our students when I'm at home? So you can see me at my desk with lots of computers at home demonstrating a physiological experiment. And even now going back to work and teaching with our mask on, we have to continue to create opportunities for learning and opportunities to nurture curiosity. Next slide. And what I want to leave you with, that part of my journey into science has been a combination of feeding curiosity, being curious, following curiosity, and awakening it in others. And so it is my hope that during the time we've spent together, that you continue to be curious. And if you find yourself a curious person, follow your curiosity, find opportunities to nurture it, and then give back and let others be awakened to their own curiosity. Thank you.
Thank you, Dr. Ibarra. That was an amazing presentation. A virtual round of applause. Thank you for sharing your journey and advocating for students to kind of spark that curiosity in them. So personally, what I thought was interesting was the point where you talked about what does the scientist look like? I thought that was eye-opening. So now we would like to get into some questions. One of the first questions that we have is from Advit Nair from Seven Lakes Junior High. He asks, what is your advice for young people looking to make advancements and new discoveries in the medical field?
Good question. So discoveries could be made just by reading. There's a lot of information online. There's a lot of journal articles from scientific magazines that are available free. You can go to the National Medical Library for that. Part of making discoveries is to just start reading. So reading can be done by anyone that has access to the internet. And so that's one way to start contributing to medicine, is that you start making a connection between gaps in the literature. You start looking for ways in which questions have not been yet answered, or you find yourself in a place where you become so curious about a disease that you can start making a difference. That's one way to do it from home. Another way to do that is to reach out to a scientist in an area that you're interested in. Many scientists are willing to take on a student to come in. I know in my experience, I've had a student come into my lab as early as high school, and she stayed with me through undergrad and through medical school, and now she is a resident. And so she was an example of someone that was very curious, very mature, very focused about her research, and stayed with me for many years. So most scientists are accepting and willing to have students come on board in various capacities, sometimes for a week, sometimes for summer, even sometimes for a day. And you're able to maintain these relationships for a very long time. So feel free to email somebody, to ask questions, to visit them, to go to community events where some of these scientists may be. And now with social media, it's so easy to find some of these scientists either online or through Twitter, because they're sharing their knowledge to the whole world. Hope that answers your question.
Yes, I think it does. I can say as a college student that reaching out and reading can go a very long way. So the next question that we have is from Charlie from Fulton Science Academy in Georgia. They ask, when you know that you can try to combat heart problems and arthritis, what is something someone can do to prevent these diseases?
That's a tough one. So a lot of these diseases come from a genetic background. It's not always what someone does to prevent it, but sometimes it's part of genetic. At least in my family, there is a genetic predisposition. There's also diabetes that comes along with that. And then together combined, they make it a very challenging disease to fight. However, there are some things that you can do when you don't have a genetic predisposition. And that could be something like exercising and eating well. A lot of these diseases can be prevented or slowed down by just eating well. So monitoring what you eat, for example, a plant-based diet or limiting certain processed foods, can be very beneficial towards prevention of developing heart disease. Now, rheumatoid arthritis, we don't have a true answer that says you should do this to prevent it from happening. We don't know enough about the disease yet. And that is a tough one because a lot of people get it due to genetics. A lot of people can get arthritis due to an environmental exposure of a chemical or an environmental exposure to something that they've been exposed to. So that's a little harder one, but at least for heart disease, we do know that the diet and exercise are part of the preventive strategies of heart disease.
Thank you, Dr. Ibarra. One of the, not last questions, but someone wanted to say, Uma Purani from Parkland High School in Pennsylvania. She has no question, but she would like to thank you for all that you're doing for the Hispanic community and in the world in general. She was very inspired and feeling very hopeful. So on behalf of everyone, I think we all can say thank you so much.
Thank you for the comment. I appreciate that.
Of course. So with that, I think we are going to end the speaker series. Once again, I would just like to thank Dr. Ibarra and Dr. Hawkins and the audience members for participating. We will now be taking a short 2-minute break and we will come back and get ready into Division B awards. Thank you guys.
Thank you.
Hi, everybody. We're back. I, again, thank you guys for coming in. I'm Rebecca Schooler. I'm one of two MCs tonight. I'm our communications director. And so I just want to give such a big welcome to all 760 plus of you that are here right now. We are so excited to have you. So I'll be doing our social media plug at the moment. So we'll go to the next slide. So come check us out at ATX Scioli. We are on Instagram, Facebook, and we even have a TikTok. Thank you for the 10 of you that have followed us in the last hour. Yeah, so we are really excited to be doing a lot of interesting challenges and giveaways and plugging our cool speakers on all of these social channels. So please follow us so you can stay tuned into what all we've got going on, not only this month, but in the future also. And you can get early news about our tournament info. So yeah, go check us out. Secondly, we also have a merch giveaway contest on the next slide. Perfect, thank you. Yeah, so the rules are on our Instagram. It's this one with the orange leaves. Go follow us, and then you have to repost it and tag us in your story, and then tag a friend in the comments, and that's how you get entered to win sweet Longhorn merch. On behalf of Bevo and I, we are both very excited to see what you can come up with. Just a quick announcement, for someone who asked earlier, we will be doing the Spirit Award announcement at a later time. We're trying to give more teams an opportunity to submit their TikTok or Instagram videos. So yeah, go ahead and send those in to us now that you're not busy with your tests anymore. Next, I'd like to hand this over to Ashish, our team president.
Thanks so much. You can go to the next slide. My name is Ashish. It is really great to have all of y'all competing at our tournament and to have y'all attending the live stream award ceremony. I'm the president of ATX Science Olympiad for the last 2 years, and I'm here to highlight our team. So these are some of the pictures of the people that have worked so hard behind the scenes to put this on. You can learn more about them on our website, always contact us, and we'd love to help out your team get through the challenges of this virtual semester. Together, we hosted a coaches clinic, one of the first ever virtual tournaments in the COVID-19 era. And we're even partnering with local schools to help start up new teams. This is an amazing, amazing team. And I cannot thank them enough for all that they did to help move us into a virtual format. This was such a challenge. And I'm so happy that these people were on our team to help us execute this tournament. I'll let Aditya talk a little bit more about the tournament itself, though. He is one of our two tournament directors. But first, I just want to thank our sponsors, the UT Institute of Geophysics, Student Government, Texas Parents. These people have been so generous of us, even during COVID-19, to make sure that we could put this on and eventually get medals to y'all who win tonight. So with that, we can go to the next slide, and I'll introduce Aditya Shah, one of our two tournament directors who's present tonight.
Hi, everyone. Like Ashish said, I'm one of the two tournament directors for ATX Science Olympiad, along with Anita Rhodes. I'd like to start off by thanking everybody for attending our Invitational. It's truly been a pleasure and an honor to have some of the best and brightest students in the country competing here, and we were all blown away by your hard work, dedication, and enthusiasm for science. I'd also like to thank all the parents, coaches, and especially the students for their patience and empathy yesterday. Our tournament certainly had its fair share of hiccups, and we're grateful for everybody's flexibility as we work to resolve any issues as quickly and professionally as possible. As one of the first ever virtual tournaments in the country and history of Science Olympiad, we knew some bugs were bound to happen, but we're excited and honored to be able to usher in a new era of Science Olympiad competitions. If you're running a virtual tournament this year, feel free to reach out to us if you're curious about our experiences and want to talk. Next, I'd like to give a huge shout out to Duan Duang, the developer of Scilympiad. Duan has helped us at every step of the way through our tournament planning process, and without his dedication and work, it's likely that far fewer students would be able to experience Science Olympiad in any form this year, and it's certain that our tournament would not have happened in its current form. Duan, if you're listening to this, you're the real MVP. And finally, I'd like to say to all the ATX Science Olympiad members, event supervisors, exam reviewers, and volunteers, thank you so much for your hard work towards putting on this tournament. It would have been impossible to run a tournament this large, with this many students, with such good tests, without every single person's help. With that being said, I hope you and your students have had a wonderful experience competing at the UT Invitational 2020 and found our exams challenging and fulfilling, and that you'll consider coming back next year. Now, without further ado, to Becca for awards.
Welcome back, everybody. That was just a quick snapshot of our amazing team. So next up, we will be beginning B Division Awards very shortly. Next slide. Okay, first up, we've got Anatomy and Physiology. In 6th place, drum roll please, we have, there we go, Seven Lakes Junior High. In 5th place, we have Kennedy Middle School, Team A, B32. In 4th place, we have Jeffrey Trail Middle School, Blue Team. In 3rd place, we have Fulton Science Academy 1. In 2nd place, we have Solon Middle School. And in 1st place, we have Beckendorf Junior High, Team A. Give it up. Nice job, you guys. For Division B, Botany. In 6th place, we have Iolani School 1. In 5th place, we have Orlando Science Middle School C. 4th place, Harmony School of Excellence, Houston A. 3rd place, we have Solon Middle School. 2nd place, Beckendorf Junior High A. And in 1st place, Jeffrey Trail Middle School Blue. Congrats, everybody, again. Next event is Division B Circuit Lab. Stay tuned. In 6th place, we have Springhouse Middle School B. In 5th place, we have Winston Churchill Middle School Gold. 4th place, we've got Fulton Science Academy 1. In 3rd place, we have Kennedy Middle School A. In 2nd place, we've got Beckendorf Junior High A. And in 1st place, we have Jeffrey Trail Middle School Blue. Thank you, guys. Oh, I'm sorry, I was told it's pronounced Iolani, so sorry, previous team. In Division B, we have the next event is Codebusters. In 6th place, we have Huntington Middle School. In 5th place, Mesa Robles School, Blue. In 4th place, we have Kramer Middle School 1. In 3rd place, we have Jeffrey Trail Middle School Blue. In 2nd place, we have Sierra Vista Middle School 1. And in 1st place, we have Kennedy Middle School A. Congrats, Codebusters. For their next Division B event, we have, oh, one of my favorites, Crime Busters. In 6th place, we have Sierra Vista Middle School 1. In 5th place, we have Glasgow Middle School. In 4th place, 2. And then in 4th place, we have Fulton Science Academy 1. In 3rd place, we have Jeffrey Trail Middle School Blue. In 2nd place, we have Kennedy Middle School A. And coming in gold in Crime Busters, we have Mesa Robles School Blue. Congrats. Next up, we've got Division B Density Lab. In 6th place, we have Fulton Science Academy 1. In 5th place, Jeffrey Trail Middle School Blue. In 4th place, Springhouse Middle School B. In 3rd place, Beckendorf Junior High A. 2nd place, we have Winston Churchill Middle School Gold. And in 1st place, we have Kennedy Middle School A. Congrats on Density Lab, guys. Next event is Disease Detectives. Very relevant right now. In 6th place, we have Dodgton Middle School, B12. In 5th place, we have Beckendorf Junior High A. In 4th place, Fulton Science Academy 1. In 3rd place, Seven Lakes Junior High A. In 2nd place, Jeffrey Trail Middle School Blue. And in 1st place for Disease Detectives is Kennedy Middle School A. Congrats, guys. Please go find lots of cures in the future. Next up, we have, I'm gonna do Dynamic Planet next up. We've got 6th place, Iolani School 2, Jeffrey Trail Middle School Blue. 4th place, Kennedy Middle School D. In 3rd place, we have Kennedy Middle School A. In 2nd place, we have Winston Churchill Middle School Gold. And in first place, we have Beckendorf Junior High A. Next up is food science. In sixth place, we've got Mesa Robles School Blue. In fifth place, we have Huntington Middle School 1. In fourth place, we have Kennedy Middle School C. In third place, Winston Churchill Middle School Gold. Second place, Kennedy Middle School A. And coming in gold, we've got Jeffrey Trail Middle School Blue. Now I'm going to hand it over to Isha to run the rest of the Division B awards.
Thank you, Becca. Congrats to everyone so far. So Division B fossils, sixth place we have Huntington Middle School 1. In fifth place, Jeffrey Trail Middle School Blue. Fourth place, Kramer Middle School 1. Third place, Beckendorf Junior High A. Second place, Kennedy Middle School A. And in first place, Solon Middle School B62. Congrats, everyone. Heredity, in sixth place, we have Beckendorf Junior High B. Fifth place, Beckendorf Junior High A. Fourth place, Fulton Science Academy 2. Third place, Winston Churchill Middle School Gold. Second place, Jeffrey Trail Middle School Blue. And in first place, Kennedy Middle School A. Next, please. Machines. In sixth place, we have Mesa Robles School Blue. In fifth place, we have Kennedy Middle School B. Fourth place, Beckendorf Junior High A. Third place, Winston Churchill Middle School Gold. Second place, Kennedy Middle School A. And in first place, Jeffrey Trail Middle School Blue. Congrats, everyone. Meteorology. Sixth place, we have Sierra Vista Middle School 1. Fifth place, we have Solon Middle School. Fourth place, Winston Churchill Middle School Gold. Third place, Kennedy Middle School A. Second place, Fulton Science Academy 1. And in first place, Beckendorf Junior High A. Ornithology, sixth place, we have Glasgow Middle School 1. Fifth place, Jeffrey Trail Middle School Blue. Fourth place, North Austin Science Alliance. Third place, Adams Junior High Gold. Second place, Beckendorf Junior High A. And in first place, we have Kennedy Middle School A. Reach for the stars. In sixth place, we have Beckendorf Junior High A. Fifth place, we have Sierra Vista Middle School 1. Fourth place, we have Winston Churchill Middle School Purple. Third place, we have Kennedy Middle School A. In second place, we have Jeffrey Trail Middle School Blue. And in first place, we have Fulton Science Academy 1. Good job, you guys. Rhodes Scholar. In sixth place, we have Dogen Middle School. Fifth place, we have Winston Churchill Middle School Gold. In fourth place, we have Solon Middle School. In third place, we have Springhouse Middle School A. In second place, we have Kennedy Middle School A. And in first place, Jeffrey Trail Middle School Blue. Solar power. For sixth place, we have Mesa Robles School Blue. Fifth place, we have Iolani School 1. In fourth place, we have Winston Churchill Middle School Gold. In third place, we have Dogen Middle School. Second place, we have Solon Middle School. And in first place, we have Jeffrey Trail Middle School Blue. Woohoo! Good job, you guys. Water quality. In sixth place, we have Springhouse Middle School A. In fifth place, we have Jeffrey Trail Middle School Jets. In fourth place, we have Iolani School 1. In third place, we have Jeffrey Trail Middle School Blue. Second place, Kennedy Middle School A. And in first place, we have Beckendorf Junior High A. Fermi questions. In sixth place, we have Iolani School 1. In first place, we have Dogen Middle School. In fourth place, we have the Bay Academy, B. In third place, we have Sartarsha Middle School, A. In second place, we have Harmony School of Excellence, Houston, A. And in first place, we have Winston Churchill Middle School, Gold. For Division B, we've got your number. Sixth place, we have Seven Lakes Junior High, B. In fifth place, we have Iolani School 1. In fourth place, we have Bonham Middle School, A. In third place, we have Jeffrey Trail Middle School, Blue. In second place, we have Seven Lakes Junior High, A. And in first place, we have Kennedy Middle School, A. Congrats, you guys. Okay, the moment we've been waiting for, overall top schools. So for sixth place, we have Sierra Vista Middle School 1. Congrats, everyone. Woohoo! Okay, in fifth place, we have Solon Middle School. Woohoo! Yay, you guys, virtual applause. In fourth place, we have Winston Churchill Middle School, Gold. I'm sure you guys are all very excited, jumping up and down. Woo! Okay. In third place, we have Beckendorf Junior High, A. Congrats, you guys. Did great. In second place, we have Jeffrey Trail Middle School, Blue. Woohoo! Congrats, you guys. Did great. And in first place, we have Kennedy Middle School, A. Woohoo, you guys did great. I hope you guys had a fun time competing, even though it was a virtual format. And would just like to thank everyone for Division B awards. And we will be taking another short little break, and we will get back and get ready for Division C awards. Thank you, you guys.
Hi, everybody. Welcome back to our Division C virtual UT Invitational Award ceremony. We're so excited to have all of you guys here. Just wanted to give a big shout out to the 200 teams that were competing in this invitational. We were so excited to have all you guys, and we had a lot of fun putting this on, and are really excited for all of you to be able to compete with us. So yeah, without further ado, I'm the communications director for ATX Scioli this year. We're a student-run UT Science Olympiad organization, and so we put on your tournament. We'll go to the next slide, please, Daniel. Oh, okay. So yeah, so I'm the communications director. So my job is to run our social media, basically. And please go follow us. We are at atx.scioli on Instagram and TikTok. Coaches, go check us out for your video submission in order to be entered for the Spirit Award. Quick update for those of you who asked, we are going to announce the Spirit Award later in order to give teams time to finish those videos. We know you guys are really busy competing. So yeah, next up, we also, on the next slide, have a giveaway announcement. And so the 3 things you need to do are follow us, to repost the merch competition slideshow shown here on your story, and to tag a friend in the comments. So yeah, copy posting. Next up, I'll be handing it off to our president, Ashish, who's going to tell you more about our team.
Hi, everybody. My name is Ashish Chakraborty. I'm the president of ATX Scioli. It is my pleasure to welcome you all to the Division C award ceremony for tonight. We're so happy to have all of y'all and that y'all chose to compete with us today. We had a lot of fun. We hope y'all did too. I want to highlight the members of our organization who made this possible. Some of them are listed here. These are amazing people who take time out of their weekends, their evenings, just to put on our tournaments, our outreach events. And those of y'all that have come to our coaches clinics and stuff know that we really care about helping the communities around us and the teams across the country prepare for Science Olympiad. And these are the people who make it possible. So I'm so grateful to them. You may not see them tonight, but they're really all here. And you witnessed their work when you took their tests and we troubleshot your problems. So I'm very, very proud of them. And I also wanted to spotlight our sponsors, the UT Institute of Geophysics, Texas Parents, student government have all been really supportive of our mission here. And we're so excited to have their support going forward. I hope y'all were able to catch some of our speakers earlier. They were fantastic, but you'll see this live stream posted later on and you can go back and watch them if you would like. And honestly, I'm sure they would love if you reached out to them to ask them some questions afterwards too. Without further ado, I'll pass this on to one of our 2 tournament directors, Aditya Shah. And you can go to the next slide.
Hi, everyone. As Ashish said, I'm Aditya, one of the 2 tournament directors, along with Anita Rhodes. First, I'd like to start off by thanking everyone for attending our invitational. It's truly been a pleasure and an honor to have some of the best and brightest minds in the country competing here, and we were all blown away by the students' hard work, dedication, and enthusiasm for science. I'd also like to take a moment and thank all the parents, coaches, and especially the students for their patience and empathy throughout the entire tournament, especially yesterday. Our tournament has certainly had its fair share of hiccups, especially yesterday, and we're grateful for everybody's flexibility as we work to resolve any issues as quickly and professionally as possible. As one of the first ever virtual tournaments, we knew some bugs were bound to happen, but we're excited to help usher in a new era of Science Olympiad competitions. If you are running a virtual tournament this year, feel free to reach out to us if you're curious about our experiences and want to learn more. Next, I'd like to give a huge shout out to Duan Duong, the developer of Scilympiad. Duan has helped us every step of the way through our tournament planning process, and without his dedication and work, it's likely that far fewer students would have been able to experience Science Olympiad in any capacity this year. And it's certain that in our tournament, we wouldn't have been able to run it anything like this if it wasn't for Duan. So Duan, if you're listening to this, you're the real MVP. And finally, I'd like to say thank you to all the ATX Science Olympiad members, event supervisors, exam reviewers, and volunteers for their hard work towards putting on this tournament. It would have been impossible to put on such a large tournament with so many schools and so many event supervisors and tests without everybody's help. especially with us trying to get all the exams graded in just about a day. With that being said, I hope you and your students have had a wonderful experience competing here at UT and found our exams challenging and fulfilling. And we hope that you'll consider coming to our tournament next year as well. Now, without further ado, to Becca for the awards.
Thank you guys so much. It has been such an honor working on this team. And just as a reminder, Science Olympiad doesn't have to end in high school. So please come check us out if you're coming to UT in the future. We're really excited we look forward to meeting you. So we'll be starting off in Division C now. Here we go. First event, Anatomy and Physiology. In 10th place, we have Troy High School, California in red team. In 9th place, we have San Marino High School A. In 8th place, we have Harriton High School A. In 7th place, for Anatomy and Physiology, we have Mason High School White. In 6th place, we have Mason High School Green. In 5th place, we have Chattahoochee High School A. In 4th place, we have Austin Area Homeschoolers A. In 3rd place, we have Hillsborough High School. In 2nd place, we have Troy High School Black. And in 1st place, we have Seven Lakes High School Orange. Next event, we have Astronomy. In 10th place, we have Montgomery High School B. In 9th place, we have Austin Area Homeschoolers A. In 8th place, we've got Mountain View High School Bread. Nice, nice. In 7th place, we have Camas High School Graphite. In 6th place, we have Stephen F. Austin High School Alpha. In 5th place, we've got Seven Lakes High School Orange. 4th place, Mason High School Green. In 3rd place, Mason High School White. In 2nd place, Troy High School Black. And in 1st place for Astronomy, we have Syosset High School. Congrats, you guys. Next up in our Division C events is Botany. In 10th place, we have Mission San Jose High School Lime. In 9th place, DuPont Manual High School. In 8th place, we have Texas Academy of Mathematics and Science. 7th place, we've got West Windsor Plainsboro High School North. And in 6th place, we have Hillsborough High School. In 5th place, we have Stephen F. Austin High School Alpha. In 4th place, we have Syosset High School. In 3rd place, we've got Troy High School Black. In 2nd place for Botany, we have North Hollywood High School. And in 1st place, we have William P. Clements High School B. Congrats, everybody. Next up, we've got Chemistry Lab, Division C. And for that, we have, in 10th place, we've got Iolani School Artichoke. In 9th place, we have Montgomery High School B. In 8th place, we've got Lake Braddock High School. In 7th place, we have Stephen F. Austin High School Alpha. Coming in at 6th place, we've got Bethlehem Central High School. Sorry, guys. Congrats. And in 5th place, we have Novi High School B. In 4th place, we've got Troy High School Black. 3rd place, Lower Merion High School A. 2nd place, Seven Lakes High School Orange. And coming in at 1st place, we have Seven Lakes High School Gray. Congrats, everybody in Chem Lab. Next up, we have Circuit Lab. In 10th place, we've got Mason High School Black. 9th place, Troy High School Black. 8th place, we've got Mountain View High School Mochi. 7th place, Hillsborough High School. 6th place, Mason High School Green. In 5th place, we've got Lower Merion High School A. Coming in at 4th place, we have LASA, or Liberal Arts Science Academy B. 3rd place, Seven Lakes High School Gray. In 2nd place for Circuit Lab, we have James S. Rickards High School 1. And in 1st place, we have Seven Lakes High School Orange. Congrats, everybody. Next up, we've got Codebusters for Division C. Coming in at 10th place, we've got Milpitas Blue. 9th place, we have Seven Lakes High School Orange. 8th place, Montgomery High School A. 7th place, Stephen F. Austin High School Alpha. Sixth place, Mission San Jose High School Lime. Fifth place, Troy High School Black. Fourth place, Seven Lakes High School Gray. In third place, we've got Mason High School Green. In second place, we've got William P. Clements High School B, and taking the gold for Codebusters, we have Syosset High School. Next event we have is Data Science for Division C. Coming in 10th place, we've got Summer Creek High School. In 9th place, we've got Camas High School Carbon. 8th place, Syosset High School. 7th place, Montgomery High School B. In 6th place, Middlesex County Academy for Science, Mathematics, and Engineering and Technologies. In 5th place, West Windsor Plainsboro High School North. 4th place, Montgomery High School A. And coming in 3rd place, we've got Lower Marion High School A. 2nd place is William P. Clements High School B. And in 1st place for data science, we have Stephen F. Austin High School Alpha. Congrats on data science, guys. Next up, we've got designer jeans. We've got Iolani High School Artichoke in 10th place. 9th place, we have Brookwood High School C. In 8th place, we have Troy Athens High School Red. In 7th place, we have Mission San Jose High School Marigold. In 6th place, we've got American High School Blue. In 5th place, we have Harrington High School B. And 4th place, we have Troy High School Black. 3rd place, we've got San Marino High School A. In 2nd place, we have North Hollywood High School. And coming in 1st place in designer jeans, we have West Windsor Plainsboro High School North. Next up, we've got the Tector Building. In 10th place, we have Lower Marion High School A. In 9th place, we have Mason High School Green. In 8th place, we have Seven Lakes High School Orange. In 7th place, we have James S. Vickers High School 1. In 6th place, we have Hillsborough High School. 5th place is William P. Clements High School A. 4th place is Mason High School Black. Taking 3rd place in Detector Building is Lower Marion High School B. 2nd place is Troy High School Black. And coming in 1st place, we have Mission San Jose High School Marigold. Congrats, everybody, again. Next up is Disease Detectives. Very important one this year. In 10th place, we have Mission San Jose High School Lime. Coming in 9th place, we have Iolani High School Artichoke. In 8th place, we have Liberal Arts Science Academy, Team A. In 7th place, we have Seven Lakes High School Blue. In 6th place, we have Harrington High School B. Coming in 5th place, we've got William P. Clements High School B. 4th place is Hillsborough High School. 3rd place is Seven Lakes High School Orange. 2nd place is American High School Blue. And in 1st place for Disease Detectives, we have Troy High School Black. Next up, we've got Dynamic Planet. In 10th place, we have Montgomery High School B. In 9th place, we have Iolani High School Artichoke. 8th place brings us Temple City High School. 7th place, Seven Lakes High School Orange. In 6th place, we have Mountain View High School Bread. Gotta get that bread. And in 5th place, we have Mason High School Black. 4th place, Mission San Jose High School Marigold. In 3rd place, we have Mason High School Green. In 2nd place, we have Seven Lakes High School Gray. And in 1st place in Dynamic Planet is Troy High School Black. Next up, I'm going to hand it off to Isha, who will announce the second half of Division C awards.
Thank you, Becca. Congrats to everyone so far. So Division C Forensics, in 10th place, we have Great Oak High School 2. In 9th place, we have Temple City High School. In 8th place, we have Mason High School Black. In 7th place, we have Seven Lakes High School Gray. In 6th place, we have Harrington High School A. In 5th place, we have Iolani School Artichoke. In 4th place, we have Seven Lakes High School Blue. In 3rd place, we have Orlando Science High School B. In 2nd place, we have William P. Clements High School A. And in first place, we have Seven Lakes High School Orange. Congrats, everyone. Next slide, please. Fossils. In 10th place, we have Troy High School, red. In 9th place, we have Mission San Jose High School, marigold. In 8th place, we have Camas High School, carbon. In 7th place, we have Bayard Ruston High School, gold. In 6th place, we have Harrington High School, B. In 5th place, we have Seven Lakes High School, orange. In 4th place, we have Mason High School, black. In 3rd place, we have Syosset High School. In 2nd place, we have West Windsor Plainsboro High School, north. And in 1st place, we have Troy High School, black. Congrats, everyone. Geologic mapping. In 10th place, we have Obra D. Tompkins High School, A. In 9th place, we have Temple City High School. In 8th place, we have Orlando Science High School, A. In 7th place, we have Harrington High School, A. In 6th place, we have Iolani Artichoke. In 5th place, we have Mason High School, black. In 4th place, we have Mission San Jose High School, marigold. In 3rd place, we have Troy High School, black. In 2nd place, we have Liberal Arts and Science Academy, B. In 1st place, we have Columbia High School. Woohoo! Good job, you guys. Machines. In 10th place, we have Mason High School, green. In 9th place, we have Seven Lakes High School, orange. In 8th place, we have Troy High School, black. In 7th place, we have James S. Rickards High School, 1. In 6th place, we have Mason High School, black. In 5th place, we have Orlando Science High School, B. In 4th place, we have Obra D. Tompkins, A. In 3rd, we have Liberal Arts and Science Academy, B. In 2nd place, we have Stephen F. Austin High School, Alpha. And in 1st place, we have Mission San Jose High School, Lime. Congrats. Ornithology. In 10th place, we have Milpitas, gold. In 9th place, we have Mission San Jose High School, lime. In 8th place, we have Mason High School, white. In 7th place, we have Seven Lakes High School, blue. In 6th place, we have Mountain View High School, bread. In 5th place, Mountain View High School, mochi. In 4th place, we have Harrington High School, A. And in 3rd place, we have Harrington High School, B. And in 2nd place, we have Mason High School, green. And 1st place, Mason High School, black. Congrats. Protein modeling. 10th place, we have Troy High School, red. In 9th place, we have Mason High School, black. 8th place, American High School, blue. In 7th place, we have Troy High School, black. 6th place, Seven Lakes High School, gray. 5th place, Iolani School, artichoke. 4th place, Syosset High School. 3rd place, Seven Lakes High School, blue. 2nd place, William P. Clements High School, B. 1st place, North Hollywood High School. Woohoo! Doing great, everyone. Solar power. 10th place, we have Middlesex County Academy for Science, Mathematics, and Engineering Technologies. In 9th place, San Marino High School, A. 8th place, Milpitas, blue. In 7th place, Hillsborough High School. 6th place, Mason High School, white. In 5th place, Cinco Ranch High School. 4th place, Liberal Arts and Science Academy, A. 3rd place, West Windsor Plainsboro High School, North. In 2nd place, Iolani School Artichoke. And in 1st place, Colleyville Heritage High School. Woohoo! Division C, Sounds of Music. In 10th place, we have Lower Marion High School, B. In 9th place, Mason High School, white. 8th place, Liberal Arts and Science Academy, B. 7th place, Mason High School, black. Sixth place, Montgomery High School A. Fifth place, Camas High School, Carbon. Fourth place, Mission San Jose High School, Lime. Fourth place, Hillsborough High School. I think I said fourth, I meant third place. Second place, American High School Blue. And in first place, Mason High School Green. Congrats, everyone. Water quality. In 10th place, we have Mason High School Green. 9th place, Mountain View High School Mochi. In 8th place, we have Troy High School Black. In 7th place, we have Harrington High School B. In 6th place, we have Iolani School Artichoke. In 5th place, American High School Blue. In 4th place, we have Montgomery High School B. And in 3rd place, we have Mason High School White. 2nd place, Oberty Tompkins A. And in 1st place, we have Bayard Ruston High School Blue. Good job, you guys. Fermi questions. In 10th place, we have Colleyville High School, Heritage High School. In 9th place, we have Oberty Tompkins High School B. In 8th place, we have San Marino High School A. In 7th place, we have West Windsor Plainsboro High School North. In 6th place, we have Central Texas Science Team. In 5th place, we have Mission San Jose High School Lime. In 4th place, we have Syosset High School. In 3rd place, we have Mountain View High School Bread. In 2nd place, we have William P. Clements High School B. And in 1st place, we have Colleyville High School, Heritage High School. Congrats. Ooh, we've got your number. In 10th place, we have Langham Creek High School A. In 9th place, we have John Foster Dulles High School A. In 8th place, we have West Windsor Plainsboro High School North. In 7th place, we have Colleyville High School, Heritage High School. I'm sorry, guys. In 6th place, we have Central Texas Science Team. In 5th place, we have San Marino High School A. In 4th place, we have Oberty Tompkins High School A. In 3rd place, we have Texas Academy of Mathematics and Science. In 2nd place, we have Stephen F. Austin High School Alpha. And in 1st place, we have William P. Clements High School B. Okay, the moment we have all been waiting for. So for Division C, overall top schools. So for 6th place, from all the way in New Jersey, we have West Windsor Plainsboro High School North. Congrats, you guys. Round of applause. You did great. Okay. In 5th place, from the state of California, we have American High School. Woohoo! We're all clapping virtually. Congrats, you guys. In 4th place, from Hawaii, we have Iolani School. It's kind of weird, but a round of applause. Congrats, you guys. You did great. Okay. Top 3. In 3rd place, from Ohio, we have Mason High School. Ooh, good job, you guys. In 2nd place, from Texas, we have Seven Lakes High School. Congrats, you guys. Did an amazing job. And in 1st place, from California, we have Troy High School. Congrats, you guys. All of you guys did great. It was a pleasure to MC this along with Becca. And just to reiterate, we will announce the winner of the Spirit Awards all on our Instagram. So definitely be on the lookout. Obviously follow us on Instagram and Facebook and our TikTok. And because we will have a lot of fun stuff going on over there with giveaways and everything. And before we end, I'm just going to hand it off to Ashish.
Sure. So thanks again, everybody, for coming out. We really, really appreciated having you. Just another plug to follow us on social media. We'd love to engage you in our giveaways and our activities, and you can spotlight your school as well. Our tournament committee worked really hard to put together stickers for our event, and if you'd like to order some, you can have your coaches check their email or our website, and they're pretty cheap and they're really well designed. And then Becca, did you have anything you wanted to add?
No, that pretty much covered it. We were so excited to have all of you guys out here on our award ceremony. Please feel free to tag us in any pictures. I've already seen some really cool stories about how teams are watching this together virtually. And we've really appreciated all of the sweet messages we've gotten about how much y'all enjoyed this. So please feel free to keep it coming. We were so excited to see all you guys on this live stream, although it is a very different reality. So keep it up, keep up the good work. And yeah, thanks for coming out.